And welcome viewers to the Daily Space Weather. We've got massive coronal mass ejections happening as we create the video. We've got new sunspots forming and plenty more to cover today at the Smash News Network Least Busted Name in News. Thanks for tuning in. Congratulations on realizing the channel exists. We're actually going to show you sunspots early on today's video. Here is the past 24 hours, and that's the SDO continuum plus 1600 angstroms, which is ionized carbon. You see all those bright white spots? Those are areas of high carbon content. Now, again, we're going to show you some close-ups here to start out today's video, since we've got some new sunspots. So here is an equatorial zoom. These are all 24-hour videos, by the way. Large group of sunspots in the northern hemisphere, large sunspot in the southern hemisphere, and an attractive group there in the southeast. This new group, 3315. We've also got 3316 just formed up here, slightly north of the equator. So here's that large group in the northern hemisphere. Some great imagery there from SDO. We'll also show that large group in the south, that sunspot there, just the umbral portion, significantly larger than the entire planet Earth. And let's briefly focus on 3315, as it has been growing a little bit since yesterday. It is also increasing the likelihood of solar flares, which have been minor over the past 24 hours. Now, don't worry, we're going to get back to some additional imagery here. Here is your colorized magnetogram. That is yesterday plus today, as you may have come to expect from the channel. And let's take a brief moment to see what's going on planet Earth. But first, take a moment to visit our links. Our paid affiliate / sponsor link is our Hemp Lucid shop. So you can find a link below this video in the description to the Hemp Lucid shop. Make sure you enter the promo code SMASHOMASH to save 10% on your checkout. Enter the promo code SMASHOMASH to save 10% on checkout at the Hemp Lucid shop. So scope that out, shop via our link. Again, it is below the video as well as on our homepage at smashomash.com. If you're unable and or unwilling to open your cobweb-encrusted wallet, then why not help us out with clicks? Smashomash.com is the official homepage of the Smash News Network Least Busted Name in News. In 2019, a crack YouTube unit was sent to social media prison for a crime we didn't commit. We promptly escaped a maximum security social media stockade to the internet underground, where we survive as producers of fortune. If you have a problem, if no one else can help, and if you can find the content, maybe you can hire the Smash team. No, you can certainly hire the Smash team. Links on the homepage to that as well, thanks to Gold and Silver Smash team members, as these videos were brought to you in part by Silver and Gold Smash team members, as well as Smash staff and I at massive personal risk and expense. Check it out. Here is Fuego. Some great time-lapse imagery there of Fuego, as it's been producing ongoing glowing, and of course lava fountaining and lava flows. New real estate being created there at Fuego. Let's see what else is on the list. The list also includes Abico, which is producing a 12,000-foot plume of volcanic ash. Please do not pole vault the caldera. Sakurajima also producing a 12,000-foot ash plume. Subanosejima, 6,000-foot ash plume. Popocatépetl, 25,000-foot ash plume over central Mexico. Fuego, again, it's degassing, and it's a near constant nighttime glow, and the ongoing degassing suggests continued surge of fresh magma within the conduit. So continuing eruptions there at Fuego. Nevado de Ruiz, 21,500-foot ash plume as Nevado de Ruiz explodes in Colombia. It's a flight level 215. Sangay in Ecuador, flight level 200 as it explodes, and Sabancaya, flight level 210 as Sabancaya explodes in Peru and produces a 21,000-foot plume of volcanic ash. Here's the past 90 days in a convenient bar graph, courtesy of volcanodiscovery.com. And there was one large quake over the past 24 hours. It was a 6.6 magnitude here in the Gulf of Darien, right near the Panama-Colombian border. So there is the location of that 6.6 magnitude earthquake. It occurred at 3:05 Universal Time this morning on May 25th. And you may be wondering if that produced any tsunamis, and the answer is not likely. So no current warning, advisory, watches, or threats for tsunamis. Let's see what else has been shaken. Papua New Guinea had a 5.0 in the past 24 hours. That was at 13:15 Universal Time yesterday afternoon. The Bande Sea also had a 6.2. There's a location of that one. That was at depth, over 160 kilometers estimated depth. There was also a 5.0 southeast of the Loyalty Islands. That is an aftershock following multiple 7 magnitude events. Fiji had a 5.0 at over 600 kilometers estimated depth. Again, there's that 6.6 at the Panama-Colombia border region, just north of the isthmus. And that closes out the list of 5+ magnitude quakes. It's time to get back to space. So here's the past 24 hours, and we're going to have some fantastic zoom-ins of coronal holes. Here's 171 plus 211 angstroms for the past 24 hours from SDO. Again, a new sunspot just formed up here. These active regions here do not appear to be sunspots. They at least were not sunspots when we did show prep. Here's 304 angstroms, and another good point to bring up here is, well, there is a coronal mass ejection that is being emitted from this area in the southwest, but there's also a massive plasma filament showing up right here in the southeast. You can see that rising there over the limb. That is indeed quite a huge plasma filament. Let's take a look at that using the SDO browse data feature. Huge plasma filament over there in the southeast. That is probably an unsustainably large solar prominence there. So expect that to either collapse or eject within the next, I'll say the next 24 to 36 hours. That is a very large and unstable looking plasma filament. And again, we're talking about this area right here. It could lead to a coronal mass ejection, but based on its current location, it is unlikely to send one in Earth's direction. We'll get to coronal holes here in a minute. First, some stats. The 10.7 centimeter radial flux is now at 164 solar flux units. There is a 1-year graph to put that in context for you. The radial flux is the black line. The sunspot number is the red line. And solar enthusiasts may be aware of the fact that the radial flux and sunspot number are directly proportional. Space Weather Enthusiast Dashboard. This is NOAA's forecast for space weather. Expecting a little geomagnetic storm tonight and a geomagnetic unrest situation tomorrow night on the 20th. Wait a minute. Let's try that again. Expecting geomagnetic unrest tonight with a KP4. Besides that, no space weather on NOAA's forecast. Again, that's a Space Weather Enthusiast dashboard if you want to follow that yourself. And now we're looking at Earth's magnetic moment from space for the past 4 hours. We do have a quite elevated solar wind here. However, the density is quite low. So while we're seeing a high-speed coronal hole wind stream, it's not having much of an effect. It does not seem to be exhibiting super strong magnetic fields. Anyway, we'll let that play through. Again, that's the last 4 hours of Earth's magnetic moment from space. the geospace magnetosphere movie, depicting the equatorial plane on the left and the meridional plane on the right. Here's Earth's magnetic moment from the ground. Things are geomagnetically calm, and if they were becoming storm conditions, this would be one of the great data sets to help you determine whether or not the aurora might be visible at your location. So try using the ground magnetic perturbations map next time you have the possibility of aurora, and maybe you'll see some. Make sure you take video or photographs of the aurora, as the aurora is largely in ultraviolet light. In other words, it's largely invisible to the naked eye, but your camera will pick up more spectra than you're able to see. Current geomagnetic conditions are calm. KP3 is the planetary K index, a general average of global geomagnetism. And next, looking at the real-time solar wind, 2C. Again, an elevated solar wind speed here. It got all the way up to the mid-600s there, 660. Some brief periods of sputtering high-speed coronal hole wind there, 652. But the density is very low, and the magnetic field is kind of all over the place. So we're not seeing a strong negative BZ up here, and hence that coronal hole high-speed stream has been a dud so far. The most recent data shows us a 645 kilometer per second solar wind speed. That's pretty quick. Solar wind density here, less than 1 proton per cubic centimeter. That's pretty diffuse. By the way, about coronal holes, important feature here that we may not have mentioned on the channel, maybe ever, maybe only once or twice. If you head to solon.info/solar, solon.info/solar, if you scroll down past all of the charts and data and archives, after you get to the recent activity portion, you'll find a section below the flares where you can look up the coronal hole history since October of 2022. Super fascinating, and it's a nice, convenient set of data here. I mean, you can go all the way, if you want to know what was happening in, I don't know, 2015. There was a southern coronal hole known as coronal hole 675. It caused a KP3 and 5, and it reached winds of 558 kilometers per second. It'll also tell you when it's a repeating coronal hole. In other words, it gets a new name when it rotates all the way around the sun, but then it gets another name. So it also does include that information. Great information there on solon.info if you want to compile data about coronal holes and things like that. Next, looking at magnetic data. The GOES magnetometers there, showing some spiky readings. No real surprise there. Again, there is a coronal hole high-speed stream buffeting Earth's magnetosphere. Next, looking at the heliospheric current sheet. And by the way, see our live streams, as we did one yesterday, that explains some of this Gong 2 data. Earth is in a South Pole current sheet. There is a North Pole current sheet approaching. It may be here as early as tomorrow. I suspect it might still not be here by tomorrow's space weather video. And let's take a look at some more magnetic data. Keep in mind, this is derived from 51 ground-based magnetometers. Magnetometers on stereo B and stereo A. And there's the latest image. North Pole current sheet approaching. This is called a sector boundary crossing. Next, our line of sight field plot. There is a lot of magnetic organization on the Earth side of the solar disk. Here the sun's B field is depicted in blue, north polar field in green, south polar field in red, which brings us to coronal holes. So there's our coronal hole line of sight plot. We do have at least one coronal hole rotating in here of northern hemisphere polarity. And here's the latest image. We're going to show you some amazing close-ups of coronal holes. So there's the latest image. And here is our coronal hole view. That's 211 angstroms from SDO. And basically what's going on here is these are South Pole. This is South Pole. And there's one over here that's North Pole. It will become more well-defined in the coming days. The sector boundary crossing is somewhere around there where that line is. Anyway, check it out here, some close-ups. Here's this great coronal hole in the northern hemisphere. What's that? You want to see it closer? Now, coronal holes are like low-pressure systems on the sun, folks. Coronal holes are of such low pressure that there is material blasting out of them. So this is like a fountain in many ways, as there are protons flying out of there. So it's one of the sources of high-speed solar wind. You could consider a coronal hole to be like a low-pressure zone. It's just that stellar low-pressure zones are so low that they blast material out into their stellar systems, this one being the solar system. Stars, they don't behave like planets. I have heard people idiotically stating on YouTube that sunspots are just like hurricanes, and that's the exact opposite. As hurricanes are low-pressure zones, and sunspots are like high magnetic pressure zones. They also occur at the photosphere, and keep in mind coronal holes are holes in the sun's atmosphere. So there's another great one in the southwest. Great detail of that coronal hole there. And let's show that one even more closely. Great coronal hole view there. It's a pretty gaping gash in the sun's atmosphere. Yeah. So, yeah. Again, those are the source of high-speed coronal hole wind streams. In fact, the one that's currently striking Earth's magnetosphere is from that coronal hole. And these were not discovered until the 1970s, as they can't be seen from the ground level. These 211 angstroms wavelength views, these are extreme ultraviolet light, which is filtered out by Earth's atmosphere. You've got to be in space to see these spectra. Let's get to sunspots next. Whoa there now. Let's get to sunspots next. And here is your flare monitor and sunspot readout. So we do have one more group that will get named today, most likely. It's 3316. It just formed up here north of the equator in the northeast. And here are some views. That's the past 24 hours in SDO continuum. Again, right there, 3316 will be the name of that new sunspot group. Lots and lots of sunspots on the Earth-facing portion of the solar disk. You can expect another uptick in the sunspot number and the radio flux today. Next, we're going to go to energetic particles and solar flares. Here's the energetic particles view. The Agos proton flux. It's still flatlined, and flaring has been minimal. I mean, there was a decent M-class flare yesterday. That was an M1.9. And also a much smaller M1.02 class flare. And once again, while we create the video, there's a flare happening now. Has it peaked out yet? Let's check the 6-hour view. It doesn't look like it's peaked out yet. And we will show you the location of that flare here in a moment. First, some more 24-hour SDO videos. So here is 171 plus 131. And we're going to swap out the 171 angstroms for 94 angstroms. So there's 94 plus 131. And we've got major flare players right on the Earth-facing portion of the solar disk here. So if we do see large flares from those sunspot groups, they could certainly cause some Earth effects like Earth-directed coronal mass ejections. Fingers crossed on that. We'd be delighted to see more aurora here in Lehigh Valley, Pennsylvania. Next, let's take a moment to look up. As we encourage our viewers to look up, this is what's going on overhead in Lehigh Valley, Pennsylvania. Just press the Now button once you have your location in there, and you can create your own star chart. If you want to know what's setting, well, Sagittarius is setting over there in the west, over Lehigh Valley, Pennsylvania. If you look straight up, you might see the summer triangle consisting of Deneb, Vega, and Altair. Also, Venus should be visible in the night sky. Rising a couple hours after the sun there, Venus, the third brightest object visible from Earth. And here's your solar system forecast. So here's where things are now. Mercury is breaking ranks with the terrestrial planets and going over to join the gas giants. Earth, Venus, and Mars on the opposite side of the sun from Saturn, Jupiter, Neptune, and Uranus. Anyway, here's your 1 week solar system forecast. That's where things will be in 7 days on June 1st. And that means something to somebody who is doing astrology, which, by the way, is starting to look more and more like cosmology. Anyway, here are your coronal mass ejections for the past, well, for yesterday and today. These are yesterday's coronagraphs. And there were some CMEs, like that one out of the east. It is unlikely to be earthly directed, to have any earthly directed components, but don't worry, we'll show you more imagery of coronal mass ejections because, hey, they're pretty exciting. So here are today's 40 more frames. And here's the Soho Lasco C2 and C3. So there is a CME actually right now propagating out of the southwest. So you're going to see that it's a massive CME. It's going to be coming out like this, and there you can see it starting to propagate. Again, that is a huge coronal mass ejection. It is unlikely to be earthly directed. It's largely on the far side there. It's behind the southwestern limb. And of course, we've got additional views for you here. We'll show you the view from Stereo A. There is a location of Stereo A. We show that daily as it is catching up to Earth. It's going to pass Earth, and Earth is passing Stereo B, so we're getting less and less angle on being able to see what's going on, and it's making it much more difficult to calculate the trajectories of coronal mass ejection impacts. Here's Stereo A on the left, and Soho Lasco C3 on the right. And thanks for leaving comments, Mr. Bordages. Next, we'll look at we've got to show our custom CME images. There are some CMEs. Again, not likely to be earthly directed. We'll zoom in a little bit. See that huge CME just making its way out of the southwestern limb there on our 24-hour video. Again, very unlikely to be earthly directed there. And you'll see why here in just a moment. First, let's talk about solar filaments. There are a massive number of very large solar filaments on the Earth-facing portion of the solar disk. These are the kind of things that can turn into coronal mass ejections. And this one up here is quite huge. This one over here is unsustainably huge. It will collapse or eject. Anyway, that's the ground-based solar observatory depicting hydrogen alpha, 6,562.8 angstroms from Udaipur, India. And as that CME propagates, here's the imagery from the GOES 16 SUVI. So that's some pretty sweet imagery, right? That is a massive coronal mass ejection. It's interestingly swirling in a counterclockwise fashion. That is quite interesting indeed. So just stunning imagery there from the GOES. That's the GOES 18 SUVI, actually. That rotating plasma mass there. It's like a giant flux tube. Again, if you were looking at the southwestern limb, it would be rotating counterclockwise, it looks like. Which is really not all that common. That uniform rotation of the entire plasma mass. Pretty sweet. Which brings us to our bonus features segment. So we don't just cover the everyday daily space weather stuff. Sometimes we show some more in-depth stuff. And, before we get to bonus features, how about the last 24 hours in SDO 193 angstroms? How about them apples? Anyway, Satellites Community Dashboard is where we're starting out our bonus features segment today. We do have some satellite charging hazards there of the surface charging variety over the East Pacific. So low energy electrons are building up on some spacecraft there. Again, the East Pacific moving to the Central Pacific soon. The GOES electron flux here, just toying with warning levels there for both the GOES 16 and GOES 18's radiographic measurements. They measure that electron flux at the F layer of the ionosphere. Here is the 1 year graph of the greater than 2 mega electron volt electron flux. That's from Solon.info as well, by the way. And here is the forecast model. NOAA expecting slightly higher levels there of electron flux. No arguments from me there. Again, keep in mind that is measured around the F layer of the ionosphere, which is located around 300 kilometers of altitude. Feel free to pause the video on this frame if you're not familiar with the electromagnetic radiation penetration and so forth. Now, what we were talking about earlier was the way you can't see coronal holes from the ground level, and that 211 angstroms wavelength we were viewing is the extreme ultraviolet spectra. So as you can see here, you've got to be above the mesosphere. You've got to be in the thermosphere to be able to see that extreme ultraviolet spectra, like what the SDO covers, which is why it is in space. So that extreme ultraviolet does not make it to the ground level. It is filtered out before it even reaches the mesosphere. So anyway, here is the vibrational frequency of the F layer. There are significant low frequency anomalies. We cover it daily on the channel, as we are rich in facts. We endeavor to make the videos as dense as possible, and we endeavor to make our viewers' brains as dense as possible. We don't want dense viewers. We want viewers with dense brains, as dense brains are associated with high IQs. So if you shove a lot of info in there, it's not really going to raise your IQ very much, but hey, increase your brain density. Use it or lose it, folks. Evolve or die. These are just basic facts of nature. Anyway, again, lots of low-frequency anomalies happening here on the anomalygram. That's anomaly in megahertz from a 30-day median. And let's briefly show the latest images. There is the ionogram showing megahertz. And there is the anomalygram showing anomaly in megahertz from a 30-day median. Significant low-frequency anomalies in the southern hemisphere, the Indian Ocean, the Middle East, and the Western Pacific. Huge ionospheric low-frequency anomaly there over the Philippines as we create the video. We'll also show the total electron content, which is useful for GPS users, as it'll show you the most likely places for GPS errors. That is the free electrons to about 12,500 miles of altitude. Let me shrink that down one size so we can see the progress bar. We'll let that play through one time. And we do indeed have some electrons out of place here. This is usually more orderly with these higher levels of electron flux right now, not so orderly. Keep in mind there is a coronal hole wind stream striking Earth's magnetosphere. Next, this is the anomaly from the 10-day average for just the North American total electron content. If we're going to start showing this in super great depth and trying to use it for predictive value, we've got to start somewhere, and I guess that place will be over North America. Keep in mind, we make these space weather videos for the sake of cosmology and the advancement of human technology. And if you want to read more about why we make the videos, well, head over to smashomash.com/forum/mission, and you can read all about it. Our bonus features segment is going to end with the latest SDO intensitygram. There's the refresh. And the latest SDO magnetogram. Again, this sunspot group is looking promising. It's very symmetrical there, and typically real symmetrical sunspots don't produce large flares, but it does involve the plasma environment also. So, the most likely place to see a major flare is still from this group, followed by this group. And there still is some likelihood for a flare from this group, as there are opposite polarity umbrae there. And this new sunspot group up here, it's already beta gamma class. There are the fields. You can see the leading North Pole umbra there and the trailing South Pole umbra. That is a more magnetically interesting type of sunspot than an alpha class sunspot, which only has one polarity umbra. This brings us to our meteorology segment. And we're starting out looking at the strongest winds in the world, which are this quite nasty tropical system. We were seeing winds in excess of 100, there we go, 107 mile per hour winds there. That is the windiest place in the world, just to the west of Guam. So that's just the surface wind map from nullschool.net. And by the way, we do have some imagery of that. The aftermath at Guam. So here are some images of some destruction. At least one truck was flipped on its side. So lots of damage as trees merge with cars. So that's what's going on. I don't know who that guy is, but he has been cut. He has been sacked. Anyway, here are the surface winds of the eastern world. Check it out. There's some weird wind currents over Australia. The wind just comes up and then ends. Check it out. That's pretty weird. I think I ever saw that before. Probably indicating a pressure gradient, but continuing on to the jet streams. And indeed, there is a strong jet stream there over Australia. Also a significant jet stream component for that. Is it called a typhoon? I think it's called a typhoon. I don't know. It's a tropical cyclone. I'll just keep it generic. So those are the jet streams of the east. Here are the jet streams of the central world. Here are the surface winds of Europe, Africa, and the Middle East. Surface winds of the west. And there are the jet streams. Here's your temperature map. And we've got some cold temperatures forecasted here for parts of places like New York and New England. That's windy.com, by the way, as we get closer and closer to the lower 48. That's the temperature situation. And here is the clouds and fog station from your satellite data interpretation. That's infrared spectra, by the way. It shows clouds and fog even at nighttime. You can use it to see if skies will be clear for you to view the aurora. And since you can expect about 18 more months of solar activity about where it is now or higher, well, it should be some exciting times. We're expecting to see the aurora multiple more times during solar cycle 25 way down here in Pennsylvania. We're located right about there, by the way, just west of the New Jersey border. Continuing on to our weather.gov map, this is the National Weather Service map. And if your location is illuminated on this map, perhaps head to weather.gov and click your location. That's what the key means. We do have some flood watches there, some hydrologic outlooks, as well as some hard freeze watches and some frost advisories, etc. And since we're starting out with talking about freezing, here's your temperature anomaly forecast based on the GFS 72-hour model. That's the GFS 72-hour temperature anomaly forecast. Some very cold temperatures there coming to Georgia, Florida, and South Carolina. Both Carolinas, even Tennessee, expecting like 16 degrees below normal. Keep in mind that is degrees Celsius. That's a lot of degrees Fahrenheit. Anyway, North Dakota expected to be unseasonably warm. Again, that's your 72-hour GFS temperature anomaly forecast in degrees Celsius. Here's your pressure and precipitation forecast based on the same GFS 72-hour model. Strong storms are going to sweep from west to east across Texas in the next 3 days. It's actually going to move a little bit to the southeast. And again, there's going to be a strong low that forms here right off the coast of South Carolina. That should cause some high seas indeed. If you're planning a surf trip, South Carolina is going to be a splentacular place to catch some 15-plus foot waves, probably. Once again, that's your 72-hour GFS pressure and precipitation forecast. And no, this area right here is nothing like a sunspot. It's more like a coronal hole, if anything else. Nothing like a sunspot. And here is your NASA lightning mapper. So some heavy lightning there across the central U.S. Also the Caribbean and Leeward Islands. And let's see if we have any current strikes. We did see some activity south of Lubbock. There are indeed some lightning strikes there around Midland and northwest of Abilene. Besides that, things are pretty calm over the U.S. as far as lightning. Less so around Eastern Europe and the Caribbean. Quite a bit of lightning strikes there. Lightningmaps.org is where I regularly visit when I hear thunder. Today's featured product is all of them. If you click the link below the video to the Redbubble shop, you'll find our Redbubble products. Thanks to everybody who's picked up merch. One of the many ways to support the channel, because reasons, is to pick up merch. You can also help advertise this way. I mean, not all of them are going to have things like our website on them, but some of them do. Like Smasher Price My First Scamdemic. That was a good one. Did I show them all? There is the full set of products that are currently offered as we endeavor to make astronomy and cosmology science again. We are extremely low on the nonsense and extremely high on the factual information. So help out the channel that way with merch, perhaps. Links below the video to that. You can also find a link to the Amazon store. So check out some of our picks on there as well. Help out the channel that way. Amazon.com/shop/Smashomash. And of course, you can also support the channel by becoming a member of the Smash Team at smashomash.com/Smash-Team. Links to the Hemp Lucid shop, links to the Amazon store, Redbubble, etc. Find us on social media. Help us out with clicks. Join at the bronze level if you're unwilling or unable to send us a few bucks per month at the silver or gold level. And I'm going to have to vanish as I'm getting keyed out. Smashomash.com/Smash-Team for subscription services. And let's close this mother out. Here's a U.S. Doppler radar map. Here's clouds and fog. And there is water vapor. And here is your recap. U.S. Doppler radar. Clouds and fog. And the water vapor. And congratulations on realizing the Smash News Network least busted name in news exists. Frankly, we are surprised. Thanks to all of our new subscribers. Check out our shorts if you haven't seen those. We'll see you soon with some more content. If you didn't see yesterday's live stream, make sure you check that out. It explains why we are not yet at solar maximum. Anyway, it's time for me to head back to the bunker. And in the meantime, I'll have been your host, Dan, a.k.a. Smash-O-Mash, signing off. And may that solar wind be at your back. I'm coming back, bunker. I'm coming back.